Hi guys, welcome to the session. Hello Munna, I'm Rupali. I hope all of you doing good. Now this is the second session of integration, right? And today what we're going to be basically talking about is definite integration. In the last session we talked about indefinite integration. In this session we'll talk about definite integration. Hi Prateek, welcome to the session. Okay, so without waste of any time, let's get started. Just a moment. I have something to fix. Yeah. Okay. Hi, Harsh. Welcome to the session. Okay. So let's get started. Look, basically, I've already talked about what is the importance of integration if I talk about JEE Mains and Advanced, right? So in today's class, we'll talk about definite integration. In fact, I'll talk about primarily just one property, which is called as the master property of definite integration. What is that? The master property. So primarily, most of the questions could be done by using this property as the initial step to begin with. Hi, Anand, Piyush, Kedar, and Yatesh, Sachin, Sahil. Everyone, welcome to the session, guys. Good evening, everyone. Okay, so now stay focused and understand whatever I'm trying to tell you. These are few things I'll just first of all revise, and then we'll apply these things to the questions which we're going to be doing or picking up for the day. Hi, Varun. So the property is simple. If there is an integration from a to b fx dx, then this is also equal to integration from a to b f of a plus b. I hope everyone knows about this. A plus b minus x dot dx, right? It's a kind of simple property to understand as well as to apply. And it's a very, very important property. Yeah. Look, it is simply stating, this property simply states that whatever the limits, the lower limit and the upper limit is, you can take the sum of these limits and subtract x from them and replace this x by a plus b minus x. I'll pick a few examples to explain this. In fact, you can go ahead and pick the example like this. See, if I say a is equal to 0, if I'm saying a is equal to 0, right? So in this case, I can generate a different stuff altogether. So it will be 0 to b fx dot dx. This is also a property which you can apply. So from the above property, what we can do is, from the above property, no Nitya. What we can do is we can write it as b minus x. Now this is also a property which we can apply and remember directly. We can apply this property directly and remember. So this is sort of the master property which can also be written in this form. I hope everyone is clear with it. It can also be modified to one more form. See, if I'm saying, let's have a look. If the limits are from minus a to a fx dx, in this case, by applying the same property, what will we get? It'll be minus a, I'm so sorry, minus a to a f of a minus a minus x. A and a gets cancelled out, right? Or minus a plus a if you want to say it that way. So this turns out to be what? This turns out to be minus a to a f of minus x dx. So you can apply this property here and there in different ways. I hope this is fine with all of us. Now over here, this property is further, is it 0 to b property, also known as King's property? Yes, Varun. Master property or King's property, whatever you want to say. This is the King's property, this is the master property, which you need to apply. Mostly, this is the property which is very commonly used nowadays. Earlier, this was the very common property. So both the properties are very, very important. Okay, so I was talking about this. One last thing which I wanted to tell you out here is, if I talk about the same, this one, based on the conclusion which we have drawn, fx from minus a to a is also equal to f of minus x from minus a to a. Therefore, if fx is an odd function, what do I mean by that? F of minus x is minus fx. If this, then the integration value will be equal to what? Anybody? Most likely everyone knows it is 0, right? And if fx is an even function, in that case, this can be written as, these are few things you already know. Just a quick revision on these. Very good. From 0, twice of fx dx from 0 to a, right? This is how we can express it. I hope this covers, yes, Sayantan. The first one, the master property, covers all the other properties. That's absolutely, absolutely true, right? Okay, so let's see. Let's go ahead and solve a few questions based on the property which we have just discussed. The very first question I'll pick up from JEE Mains 2017. So as you know that these are sessions designed to pick up just the important JEE questions. So we are picking up those questions which came in recent IIT JEE paper, and which is kind of based on the property which we have discussed. And you're going to be seeing that in almost every year, every consecutive year, you have this use of this master property. Let's talk about the question which is there on board. Very simple one. So it is integration from pi by 4 to 3 pi by 4 dx upon 1 plus cos x. Over here, if I apply this property, what will I replace x by? I can say, look, if this is I, if this is, I'm placing it equal to I, just taking few steps into consideration without writing them properly. So integration from pi by 4 to 3 pi by 4 dx upon 1 plus, we can write this x as 3 pi by 4 plus pi by 4 minus x. I hope everyone is clear with it. 3 pi by 4 plus pi by 4 minus x. And we all know 3 pi by 4 plus pi by 4 is nothing but pi. And so what we can say, look, pi minus x, this is pi minus x, cos of pi minus x is minus cos x. So this is minus cos x. Now, if I assume this I to be equation 1, I is equal to this, and this to be the second one, and if I add both of them, 1 plus 2, in this case, what will we get? If I add both of them, I'll get 2i on the left-hand side, on the right-hand side, because the limits of the integration is the same, so we can keep the integration outside and just add these two integrands. So dx, or you may say it is 1 upon 1 plus cos x plus 1 upon 1 minus cos x times dx. Good afternoon, everyone. Okay, so over here, we just need to solve this to get down to the answer. It's a very simple question from here onwards. So as soon as we're going to take the LCM, 1 minus cos x plus 1, this will be 2 upon 1 minus cos square x. Hopefully everyone is clear. Dot dx, right? Which is equal to 2i. Or we can write this 1 minus cos square x as sine square x. Sai Prasad, I understand cos is even. Cos is even. I am not applying the property which was the extension to this property. We can solve this question by a simpler method. Though you can apply that or as well. You can take this as 0 to 3 pi by 4. No, in fact, ये तो negative है नहीं ना. This is not minus a to a. So you can't apply that property, even if it's even or odd. Okay, so we need to apply this property to solve it further. So this turns out to be 2 taken common. I hope, Sai Prasad, you are clear. And this can be written as cos sec square x dx. And we all know integration of cos x square x is, this is 2i. So over here, if you want, you can cancel this 2 and this 2 and say I is equal to, this is negative cot x, upper limit and the lower limit. Right, cot pi by 4, cot 3 pi by 4 is like pi minus pi by 4 lying in the second quadrant. Cot will be negative. Negative of negative is positive. So it will be positive 1 plus 1. I hope all of us are clear with it. That turns out to be 2. So I, the integration value is 2. The answer to the question is 2. Hopefully everyone is clear with it. The correct answer to the question is B. Right. So the basic property which we have applied was what? We have applied the same property which I told you a moment back, the master one. And that is integration from a to b. Fx dx can be written as, or will always be equal to, integration from a to b, f of a plus b minus x dot dx. Let's pick up one more example. Let's talk about this. This is a JEE Advanced question. JEE Advanced 2016 question. The value of this like 2 years back. So the value of this is equal to what? So again, what we can see is that like, this is from a to b, which is minus a to a. So we can also check for even and odd function. However, over here, this entire numerator is an even function. This function cannot be classified as even or odd. Obviously, Varun, we can write that as that as well, and then we can solve. We could have solved it, right? We could have solved it. Okay. Varun, I understand. We can write that in the previous question as well, because वो sec आ जाएगा, and then we need to apply the property of sec. So you can surely do that as well, Varun. So I'm just giving you an idea that why can or how can that property be also used. So let's have a look on this as well. So, ठीक है. Over here, what will we do? We'll apply the same property. We'll say, look, let us assume that this is I. Let us assume this as I. And then if I apply the property which I was talking about, so I can say this I can be changed to x square. Look, this x will be replaced by what? A plus b minus x. So x over here will be replaced by what? Pi by 2 minus pi by 2 minus x. I hope you remember, whenever the limits are just with the difference of a negative sign, we just replace x by minus x over here, because these things will get cancelled out. So basically, I'll replace x by minus x in place of x. So this will be x square cos of minus x. This is what you're going to get. If I write it very properly, I can say that this is basically minus x whole squared. And this is 1 plus e to the power minus x, right? All right, Roy, I'm good. Tricky math, a plus b minus c wali, yeah, minus x wali property, we apply only when we have limits being defined, right? Limits being defined. Whenever a and b are given, any numbers, you can apply this property, okay? If you're talking about a plus b minus x, if you're saying c, I don't know what is that. So anyways, I hope this is fine. So this turns out to be minus pi by 2 to pi by 2. Over here, this is x square. You know, cos of minus x is cos x, even function. And this can be written as e to the power x plus 1 upon e to the power x. That can be taken over here, e to the power x dot dx. Hopefully, everyone is clear with that. So this is also I. Now, if I assume this equation to be equation number 1, this equation to be equation number 2, and add both of them, 1 plus 2. So over here, we can say 2i can be written as negative pi by 2 to pi by 2. Wait a second. Let's take a little bit more space. Negative pi by 2 to pi by 2. And then I'll add these two. So you will see x square cos x upon 1 plus e to the power x is being added by x square cos x e to the power x upon e to the power x plus 1. You can take x square cos x as common. So you don't have to write these many steps, right? You shouldn't write these steps again. Okay, Pratham, I've just applied the property of a plus b minus x over here, which gave me negative x. I've replaced this x by negative x everywhere. That's it. Okay. And then I've added these two, and I've added the two equations which I've created. So over here, if I write all the steps properly, I would say that this is basically x square cos x can be taken as common. You're going to get 1 plus e to the power x over here and e to the power x plus 1 over here, which is basically the same. So this gets cancelled out. Wait a second, Zeus. Okay. Now over here, this is an even function. This function is the function which is left, which is basically an even function. Anand, this is sort of a medium level question. It's not that easy. It's not that tough as well. So it'll be 0 to pi by 2. We already know about the property. I hope you remember. I'll just show it to you, which was kind of like, oops, like this, the property which I told you. That if it is even, then we can write it like this, twice of the function from 0 to a. If it is odd function, in that case, the answer is 0. So this is not coming out to be odd function. This is coming out to be even function. Therefore, we would say, we'll put this is an even function. We'll put a 2 from 0 to pi by 2. Okay. Now this 2 and 2 will get cancelled out. We need to solve this. Over here, this is an algebraic term. This is a your trigonometric term. So what will we apply? We'll apply ILATE, the bipart rule. So I'll just do it over here. So I turns out to be, it's an advanced question, so at least something would be checked, right? The question won't let you go just like that. By applying one master property, you are through with the answer. It won't be the case every time. So x square cos x dot dx, this is the case, or this is the value of I. And if I apply by parts over here, considering this to be the first function, this to be the second function, so I can say first function as it is, integration of the second function gives me sine x. You'll apply the limits, pi by 2 to 0, right? Minus integration from 0 to pi by 2. The derivative of this is 2x. Cos x would give me sine x dot dx. Pi by 2, once being applied, this turns out to be pi square by 4. Pi square by 4, 0 will give me 0. Minus over here, it's a simple task. We'll again apply the by parts. In fact, I'll just do it over here. If I apply the by parts over here, we can take 2 common. So x will be kept as it is. Integration of sine x is minus cos x. Minus integration from 0 to pi by 2. This x will be 1. Sine x integration is negative cos x. So this minus minus turns out to be plus. Yes, pi parts again, that's true. Minus 2 over here. Obviously, we need to apply the limits. We'll apply the limits 0 to pi by 2. Or we can apply it afterwards as well. I'll just keep it as it is. It is negative x cos x 0 to pi by 2. Plus over here, this is sine x 0 to pi by. Right. Solve it. I hope everyone will be able to get down to the answer. It's a simple question. Pi by 2 will make this 0. 0 will make this 0. So this is entirety. In the entirety equal to 0. This entire thing would turn out to be equal to 0. And over here, sine pi by 2 gives me 1. So it is basically 1 minus 0. Hence, the answer to the question is pi square by 4 minus 2. Pi square by 4 minus 2, which is A. So A turns out to be the answer to the question. I hope most of us would have integration. However, the basic thing which you need to do, the basic first step is to apply the master property, which we have discussed, that is a plus b minus x1, or the King's property, which we usually call it as. Okay. Just a moment. Okay. Just a moment. Something went wrong. What? No. Okay. Everything is cool. Okay. I thought the recording got stopped. So, all right. So let's get started with this. This is a simple question again. The integration of this is equal to what? Again, we'll be applying the same property. We'll say, look, this is I. This is I. Right. And again, we'll say, let's calculate I by applying the property, which is over here. Tricky maths. First of all, you need to know, I need to your name though, or Raju, if you're saying so. We'll apply that odd even property only when we have minus a to a given in the limits. Over here, it's 1, 2 to 4, so we won't be able to apply that. So if I apply the same property, I hope most of us will be able to get the answer to this. Achha, first of all, I hope everyone will be able to understand. इसको थोड़ा सा change कर लेते हैं. Just a simple tweak, which I hope all of us can observe as well. This is nothing but x minus 6 whole squared. X minus 6 whole squared. Or you may say 6 minus x, whatever. ये 2 to 4 है, so let's keep it as 6 minus x, keeping it as positive. 6 minus x will be a positive number whole squared. Though it doesn't matter, you can also write x minus 6 because it's eventually squared. Okay. Now if I apply the property, applying the property, what will we get? I is equal to 2 to 4. I hope you know what property am I talking about. Okay, Sayantan, sorry. So over here, if I apply the property, what will I get? Log of this will be 6 minus x whole squared. So basically, x will be replaced by 4 plus 2 minus x, which is 6 minus x. So again, over here, you will have 6 minus x whole squared. plus log of 6 minus 6 plus x whole squared. I've replaced x by 6 minus x, right? The 6 and 6 gets cancelled out. So basically, if you see, this is a new I which we have generated. Let's say this is equation 1, and let us assume that this is equation 2. Now again, if I add 1 and 2, what will we get? This is JEE Mains 2015. We did a question from 17, from 16, from 15. So you can see how much consistent this property is, which can be applied to almost all the questions which you get here and there. So if I add both of them, so you get 2i from 2 to 4, log of x squared plus log of 6 minus x whole squared. And I hope all of us can observe it very easily. Squared plus this is log of x squared dot dx. The numerator and the denominator are exactly the same, so this gets cancelled out. At times in hurry, we tend to make mistakes and tend to mark incorrect answers, right? ध्यान से काम करिएगा आप. ध्यान से काम करिएगा. So this is 2i. The integration of this will just be x. We need to apply the property 2 to 4. So it is 4 minus 2, which is 2 over here. This is 2i. Hence, I turns out to be equal to 1, not 2, right? Even after knowing the answer to the question, most of us could, get a trap or get trapped over here because we tend to forget this 2i. If the process is very long, in that case, we tend to forget this 2i, that it's being written 2i. So a better idea is to pull this 2, if you usually tend to forget, pull this 2 directly over here in the denominator initially only, so as to avoid that mistake. Anyways, the answer to the question will be 1, which is C. Very nice. Amazing. Let's take up one more question on this. The value of this integration is what? And I hope most of us will be able to do this question as well, right? One replacement I hope all of us can observe over here is this is x squared, this is x squared, this is x squared, and there is x over here. So we can assume x squared as t just to remove this x and remove the second degree term over here. These are few observations which you will surely be able to do once you'll start practicing more questions. Agar aapne shuru kar diya, you would have observed this very easily. So we can keep, or we can take this as the substitution over here, dt upon 2. We'll just replace, we'll say, look, if I replace it over there, I can say I will be, this is I will be equal to what? Up. Over here, what else will change? The limits. So we'll say when x is root ln 2, then t is what? Root ln 2 whole squared. So t turns out to be ln 2, right? We need to change the limits also, no? When x is ln 3, ln is log base e basically. So t turns out to be ln 3. Therefore, I can be written as limits from ln 2 to ln 3. X will be replaced, sorry. X dx will be replaced by dt upon 2. So you can place 1 upon 2 over here and dt will come over here. What we are left with is, just a moment, a bit more far away. Okay, so what we will be left with, sine t upon sine t plus sine ln 6 minus t. Right, a very simple question again. Now, what will we apply? We'll apply the same master property, the King's property. So what can we say? We can replace x by ln 2 plus ln 3 minus x. ln 2 plus ln 3, log a plus log b. I hope all of us remember that. Law properties can be applied anywhere in any of the questions. Log a plus log b is log a plus a into b. Log m plus log n is log mn, right? So this basically turns out to be ln 6 minus x. This is what we replace x by. So we'll say this f of this will be equal to f of this if I'm putting it inside the integration. So I can say this I turns out to be equal to 1 upon 2 was already there. B is the answer. Very nice. So this turns out to be sine of 6 minus x. Sorry, 6 minus t in this case. It is t, not x. T everywhere, you can replace it. T ho jayega because it was t, so we'll replace it by t. Sine t plus sine of ln 6 minus ln 6 plus t dot dt. And I hope all of us can see over here, if I'm adding, let's say this is equation 1 and this is equation 2. If I'm adding equation 1 and equation 2, we'll get almost a similar thing which we got in the previous case. 2i is equal to 1 by 2 integration 1 dot dt, right? Because the numerator and the denominator will be exactly the same. So we can say I turns out to be 1 upon 4 ln 3 minus ln 2. So the answer is ln 3 minus ln 2 is the way in which the answer is being written. We know plus minus what happens to the log 1 by 4 log 3 by 2. 1 by 4 log 3 by 2. Again, look, people are saying B. No, Sachin and Anushka, I hope you would have realized this. I hope you would have realized this, that you need to keep in mind that you have taken 2i over here, right? Do not forget it, please. It's very important for you to recognize that it is 2i over here. For all of us, in fact. Let's take up one more question, and let's keep this question to be the last question of the day. This is again JEE Mains 2013. So I've taken questions from 13, 15, 16, 17. All the questions are being done based on one of the properties which I just told you. So you can probably realize the importance of this property. Statement 1, the value of the integration. This is like statement assertion types question, also assertion reason types question. So, or you may say data sufficiency at times. The value of the integral this is equal to pi by 6. Anand, I understand these type of questions are the questions which we usually don't find much, hence we start hating them. These are the easiest questions, Anand, trust me. Let's have a look. The value of the integral, this is pi by 6. Second statement says this, and then we have 4 options. You need to read the options carefully. For instance, first option says the statement 1 is correct and second is also correct. And the second one is the correct explanation for the first one, right? Whenever the second one turns out to be the correct explanation, which means I'm applying this to solve this. In that case, and both of them are correct. In that case, we would select A as the answer. If that is not the correct explanation, in that case, we'll select B. If first one is correct and the second one is incorrect, then C. And if the first one is incorrect and the second one is correct, in that case, D. Most of us can see that part. Let's solve the first one first, figure out whether we are able to get pi by 6 or not. Hint is already given, use this if possible. So you will say, okay, I is basically equal to what? I is equal to pi by 6 to pi by 3 integration. And I hope most of us would be able to do it. It's a simple question. This I'll put it at easy category. So again, if I apply the same property, I can say, if this is, for instance, equation 1, applying the property, which we've just discussed, I turns out to be what? I turns out to be pi by 6 to pi by 3. So what will we replace x by? We'll replace x by pi by 6 plus pi by 3 minus x, right? Right? So this turns out to be pi by just a moment. Okay. So this turns out to be 2 pi by. So this is pi plus 3 pi, 4 pi by 6 minus x. So this is what we're going to be replacing it by. Okay. Which is pi by 2 here, 60 and 30 degree. Okay, what am I doing? I was actually reading some other comment. There is a mistake in 5th slide, probably. I'll just get back to that in a moment. So pi by 2 minus x. Let's replace it. X, when being replaced by pi by 2 minus x, will give you what? This turns out to be cot x. This turns out to be cot x, which is 1 upon 10. Hence, you can also rewrite it as. Tan x upon square root of tan x. I've written this cot x as 1 upon tan x, and I've taken the LCM, taken that square root of tan x to the numerator. And if I'm assuming this equation to be the second equation and I'm adding both of them, the numerator and the denominator will turn out to be the same. Hence, we can say from 1 and 2, what we will get is 2i is equal to integration from pi by 6 to pi by 3, 1 dot dx, which is nothing but, I hope everyone is absolutely clear with it. This is pi by 3 minus pi by 6, which is nothing but pi by 6 divided by 2, which is pi by 3. So I'll just do it over here. I turns out to be pi by 12. Pi by 6 divided by 2 is pi by 12. I is pi by 12, right? It is given pi by 6. That implies the first statement is incorrect. First statement is incorrect. So first statement correct, correct, correct. This is incorrect. This is the answer to the question. You don't have to check whether the second one is correct or incorrect. However, this is just a property which is we know correct based on the conclusion which you have drawn. How do we get the idea? Like you did in your 11th step. 11th step. Which step, Mr. Random, are you talking about? 11th step is like, yeah, Pranjali. That is something which is important. 11th step kaun sa hai? I can't count. So basically, once you will apply the property which we have discussed, Mr. Random. So after that, usually we tend to add these two and see. 11 kahin nahi likha yaar. I've written this as 2. This is the second equation here. This is the second equation. So we've just applied the property. That's what we've been discussing since the beginning of the session. Mr. Random, I hope you are clear with that. Right? This was ln6. I'm so sorry. There was a slight mistake. This was not 6 minus 6. This was ln6. So this was one of the corrections, which I believe now is fine. Okay. Okay, I hope everyone is absolutely clear with whatever we've discussed so far. Primarily, I talked about the properties which are important for you to know and remember. Know and remember. So kindly keep yourself updated. Try as many questions as possible. Second equation, kaun si? Second equation, saying something? Okay. Look, if you are unable to understand this, this is just a simple algebra here. This is a simple algebra. I have taken it like this, and then I've taken the LCM. Tan will go over there, and one tan will move up. That is it. That is it. Okay, I hope it's clear to you, Prathamesh and Mr. Raju, Tricky Maths. So bye, guys. Have fun. Prepare as hard as possible. Take tests as much as possible. And enjoy life. Don't take too much of stress because that will also put you back. Good night and have fun.